Okay, today I'm going to demonstrate 608 Design Exercise 6 Thermostat. Alright, to begin, we have a temperature of 28.74, a target of 20, and this will be cooling because our temperature is greater than our target, and as such, the LED light is blue, showing that it is indeed in accordance. Now, I'm going to re-upload the code to show that we do indeed have statefulness and that we can maintain our target even if the ESP32 is reset. So I just click the re-upload button. Now, while we wait, I'll discuss what the buttons do. So, button 3 over here. This one initiates the process of defining a new target. This one increments your new target by 1, and this one increments your new target by 10. New target always starts at 0. So that should be pretty easy to remember. Once you're done with all your increments, you click button 3 to send it up to the server, and that will set your new target. Alright, so the code just re-uploaded, and as we can see, the target is indeed 20. So that shows the statefulness. Now, what we want to see is that this also handles on our website. So let's pop over to there. This is from the most recent time I used the website. And now, if we refresh, yes, we do indeed get the target of 20. The state is cooling, temperature 28.77, which matches what we find down here. And let's just show that this does indeed update every few times. So like we just updated to get 28.799 as the temperature. We go again, 28.809999. So that does indeed show that this all works. Now, let's demonstrate that we can put in a new target. So the first thing we should do is hit button 3. Then let's set our target to be 29. 3, 4, 5, 6, 8, 9. Submit. Okay, the target is now 29, and as such, we are heating because we should be going up to reach the target, and that makes the color red. Now, I'm going to just breathe on the temperature sensor so as to show that it does indeed modify in real time, and we don't need to modify the target to modify what the LED color is. Alright, here indeed we see it went up to cooling because we went north of 29, and soon we should fall back down to get back to warming. And yeah, now that we're south of 29, we're back to warming with red. So that shows us modifying in real time. Okay, so that's just about it. All we have to do now is demonstrate this working on the web and that we can modify target from there. So here we are. We have target, we have temp, we have state. And here, let me just send it with 2042 cooling. And yeah, it spits out the 20, and we can see it on this. Note that like this temp and this state, these values, they don't matter because the system will automatically modify it with whatever it has on its own. Because at the end of the day, you shouldn't be telling the temperature through the website. The sensor should be figuring that out. So like here, if we send through 120, we'll get this output, but it won't render to the ESP32 because it's just a meaningless number. So yeah, we still get our own temperature. The target will be 20 as indicated by the postman, but temperature and cooling are determined by the ESP32. And as such, we're cooling here, so blue light. Now let's just, as a note, you don't need like the temp or the state. You can do this on its own. Let's just set this to 89. And let's send. And we do indeed see it down here on the ESP32. So it worked. And it's also red to indicate heating now. That's all good. Let's check the web service one more time. Refresh. Yep, this does indeed work as well. And yeah, that's basically all the functionality I wanted to show. They update in synchrony, the website and the ESP32. The target can be modified from both the ESP32 and the web service. All these numbers are displayed, the temperature target and the state of heating or cooling. And the LID modifies in accordance with if the sensor is heating or if we should be heating or cooling to reach our target. So that's all. Thanks.